Welcome. In this tutorial, we are going to continue user-defined function. So next topic in that series is positional and keyword argument. So what is positional argument? So the argument which are given when executing a function in order of the parameters inside the function definition. So as for the function definition self-intro, first parameter is name and second is occupation. So when we are calling that function, we are providing argument in the same order. First we are providing name of the person and second is an occupation. So calling function in this way is called as a giving as a positional argument, because here we are passing arguments to the function based on the definition of a function or the position which is defined at the definition of a function. Next type of argument is a keyword argument, which is given as a parameter name which is defined inside the signature of a function and equal to its value. Okay, so for this example self intro, we can pass keyword argument like this: name equal to the value of a name and occupation equal to occupation of a person, which will produce the same result. Okay, but main difference between keyword and positional argument is keyword argument can be passed in any order. So we can flip the order of a argument as compared to the signature of a function. So as you can see here, we are calling same function but in different order of parameter using keyword argument. So let's execute it. As we can see, it will map the string, formatted string, according to the given keyword argument. So occupation will be passed to this and name will be passed to this. So it will produce the same result as compared to the positional argument. Next topic is function with the default value parameter and its annotation. Earlier we saw that we can give a default value to a particular parameter which must come after all of the required parameters. So as you can see in the current function, we are having two parameters which are required and two parameters are default value parameter, which is not required to execute the function. Okay, but it can be given. If the value of this two parameter is given, it will be replaced by the given value. Okay, so as simple, we can only provide the flavor and size as a positional parameter and we can execute. As you can see, it will print the formatted string according to the given parameter. Now, as we saw positional and the keyword argument. Okay, so as we saw, keyword argument and positional argument can be mixed. So it is not required that when calling a function only the keyword argument must be passed. As here we can see that we are mixing with the positional argument and the keyword argument. So there is a rule for that. First you need to define all the positional argument, and then after, if you are defining a keyword argument, all the remaining arguments should be keyword arguments only. Okay, so as we can see in this example, first is a positional argument which must be mapped exactly to the first position of a given function's signature. So this will be mapped to the flavor. But from the second argument, we are providing keyword argument. Okay, so all other argument from here can be out of order. So as we can see here, the next argument which we are providing as a package, okay, which is third argument in the signature. So it will map to the package, and next argument is a required parameter which is size. So size will be mapped in here. Okay, so if we execute it, as we can see, it is formatted, string is printed as per the given argument. This is flavor, package, and size. Okay. Same way, this is also mixing the positional and the keyword argument. So first three are the positional parameter which will map same to the structure or the signature of a function. So first is mapped to the flavor, second is mapped to the size, third is mapped to the package, and last is remaining as a quantity, and it is passed as a keyword argument. So it will be mapped to that particular argument. Okay. So in here we are annotating a parameter of a function which is having a default value. Earlier we saw functional annotation with the syntax parameter name colon and after one space the type of object which is expected by a particular parameter. But if we are using it as a default value argument or parameter, we can define it like this. So this is the same parameter name colon return type or expected type of a data type of a parameter and equal to default value. Okay, and in here when defining the data type of a particular parameter, we can also give an optional value of a range. So for quantity we are defining that it must be passed integer value having greater than 0, but it will not check whether the value is given to this parameter as a greater than 0. This is just for developer purpose only. So when we are reading the documentation or when we are examining the signature of a particular function, by seeing this we can know that it needs to be passed a value which is greater than 0. Okay, so this is how you annotate a function with the default value and the range of value which is expected by the function. So if we take a look at the documentation, here we can see that from the string it has extracted the data type which is expected by a parameter quantity. Okay. Next topic is assigning a default value as a variable. So we can also use a variable or a global variable to assign a value to as a default parameter. So we need to be cautious about what happens, what is the behavior of assigning a global variable to a default valued parameter. So it is having value flavor as a vanilla, and we are defining a function and assigning that variable value as a default value to a default value parameter, and after the definition of function we are changing the value of a flavor. So if we print it, it will still print vanilla, and if we check the value of a global flavor, it returns chocolate. So what is wrong with it? So you need to keep in mind that when loading a module, so all this variable and function is defined at the module level. So when loading a module, function is loaded only once. Okay, so when it is loading the value, it will evaluate the default parameter at the load time of the particular function. So when it is loading, its value, the global variable value was vanilla, so it evaluated as a vanilla. So after loading that function, if you are changing the value of a global variable, it will not affect the default value of that particular default valued parameter. So you need to keep that in mind while using the global variable. Next topic is variable arguments, or the args. So in Python, we can have a function which takes variable amounts of argument. Okay, we have an example of a function which takes variable amount of argument is a print function. As we saw earlier, we can pass any amount of value to a print function which will print a string combining all of the given values. Okay, so if we print it, as we can see, it will print all of the value. So how it does? Internally takes the variable amount of argument. Okay, so for that we will see. So first type of a variable amount of argument is a variable amount of positional argument. Okay, so variable amount of positional argument is defined using star and the name of parameter, which will mark as that parameter as a variable number of argument. And here a rule of defining variable argument parameter is it should come after all of the required parameters. Okay, it should be defined after the required parameter. So if we have a function to get a particular ice creams, and we want to allow order of a multiple flavors of ice cream in the single function call, we can mark that flavor variable as a variable argument. Okay, so for all this fixed argument, we can order multiple flavors of ice cream using variable argument which are positional. So this is the variable argument, positional arguments. Okay, so what we are doing inside the function is, so variable positional argument will store all the given argument in the list. So here we are iterating over each argument of a list variable, and we are printing the formatted string for the given flavor. So for each variable or each arg of a flavor, we will print all these default parameters. Okay, so let's execute it. So as we can see here, first we are providing 3 parameters, which is size, package and quantity, and afterwards whatever number of argument which we will provide is considered as a variable positional argument, which will be passed to the flavors variable in the form of list. So it will return list of strings because we are providing string argument. Okay, and for that each flavor we will print this argument plus the flavor of ice cream. So let's execute it. As we can see, for each flavor it is printing formatted string of a given fixed amount of arguments. Okay, and after printing all for loop, it is printing all done. Next topic is variable amounts of keyword argument. Okay, so double star and variable parameter name marks at the beginning of the variable amounts of keyword argument. Okay, and that both the variable positional argument and variable keyword argument can be used together. Okay, but the thing is, variable positional argument must come before the variable keyword argument. Okay, so in this example we are also allowing to define custom parameter or the customization for the ice cream using this extra parameter. Okay, so anything we need to customize the given ice cream. Suppose we want to make the cone of a ice cream as a double ice cream, or take a chocolate cone instead of normal cone, then we can pass those extra parameter as a keyword argument, variable keyword arguments. So variable keyword argument will give you a dictionary object in which the key will be the name of parameter and value will be the value of a given parameter. Okay, so we can, so in this example we are, for each order we are printing that dictionary object of a extra. Okay, so if we providing two positional variable argument which are two flavors, okay, so for those two order it will print the same number of same extra dictionary object. So let's execute and see the output. As we can see, for loop have iterated two flavors which are given as a positional variable argument flavors here, and extra will contain a dictionary object which is defined in curly braces and key value pair which we are printing for each order. Okay, next topic is order of arguments. So we have seen positional argument, keyword argument, variable positional argument, default value argument, and variable keyword argument. Okay, so they have a certain rules, and this is the order of argument which must be followed, otherwise your function definition will not be valid. Okay, so let's check out the order. So first thing should come as a positional pair argument, which are the required arguments that must be passed to the function in order to execute it. After positional argument it comes variable positional argument, which will be defined as a star and the name of this. After that you can declare a keyword argument which are required keyword argument. So argument which must be passed as a keyword argument. So as we know that after, if we are defining a parameter with variable arguments, variable positional argument, and if we are defining any parameter after that variable positional argument and which is required, then that argument must be passed as a keyword argument. After this positional argument, if you pass any required argument, it will be included inside the variable positional argument. So whatever the arguments defined after the variable positional argument parameter must be passed using keyword argument, and that becomes the mandatory. Okay, after the required keyword argument, we can define default value argument. Okay, so it can be passed or not passed. So if we are defining this, the default value argument must be keyword argument only. Okay, and after default value argument, at last we can have variable keyword argument. Okay, so let's take a look at the example of it. So this is a customized ice cream method in which, as we can see here, also we have written what are the each type of order of argument which we are demonstrating. So here size is defined as a positional required argument. Okay, and afterwards we are taking flavors as a variable positional argument. So any number of positional argument can be given. Afterwards, package is a keyword argument. So this is the required argument. As we have defined a variable positional argument, it must be passed as a keyword argument only. Okay, then afterwards, this is a default value argument which is not required to call function, but if it is given value, it must be also given as a keyword argument because we have a variable positional argument before quantity. Okay, and at last we are defined extra, which is variable keyword arguments. Okay, so in this method of function, we are printing each flavor. For each flavor we are printing formatted string, and for each extra parameters or extra items we are iterating over the dictionary object, and we are printing its key and its value without breaking the line. Okay, so all will be printed in the same line of formatted string, and after iterating each flavor we are breaking the line. So let's call the function with all this argument. So as we can see here, small is passed as a positional parameter. Okay, and these are the positional parameter which will be this is also positional parameter. So until we encounter a keyword argument, all of the parameter will be passed as a flavor which will be in the form of list in this flavors variable. Okay, next is a keyword argument. Okay, so keyword arguments, package will be mapped to package. Okay, and this cone type and ice cream we don't have any here, so we don't define quantity argument, so it will be by default 1, and these are the considered as a variable keyword argument. So these are the two key value pairs will be stored into the extra. So let's execute it. As we can see here, it will print for these 4 flavors formatted string, each containing the fixed number of parameter, and at last we are iterating over the dictionary object of extra argument, which is cone type and ice cream, and we are printing the key and value for each and every order. Okay, so this is the order of argument in which you can define a parameter of a different kind. Let's take a look at the another example. In here, if we see the signature of a function, we can see here that first is a required parameter, then is a variable argument of a positional parameter, and then it is also a required parameter. As we saw order of parameters, as we can see, if we are defining a variable positional argument, and afterwards if we are defining a variable any parameter which is mandatory, it by default becomes the required parameter that must be passed as a keyword argument only. Okay, so if we execute this function like using this 1 2 3 4 and z equal to 5, 1 will be mapped to the x, 2 3 4 will be mapped to the y, because they are passed as a positional argument, and z will be mapped to the z. Okay, so let's execute it. As we can see, it contains this value. Okay, so positional argument is storing or returning value in the tuple object instead of list. Okay, all right. So if we execute this function simply like this using 1 2 and 3, it will not execute. It will give you one positional required one required argument, keyword argument z is required because of this positional variable positional argument. Okay, so all this argument it is considered as a variable amount. So by default it becomes a required argument of a keyword argument if it is defined after variable positional parameter. Okay, so this is the function call, as because it is variable positional parameter, we can ignore it too. So if we are just providing two input, required input, which is x and z, like 2, it will execute it normally. Okay, so as we can see, it return empty tuple object for that particular variable positional argument. Okay, so next example is this method signature. So in this, it is taking first 2 is a positional argument, this is variable amount of positional argument, then this becomes required keyword argument, these are the default value argument, and last one is variable keyword arguments. So if we take look at it, these are the 2 required and these are the 2 required parameter. Okay, so with passing only 4 value which is required, we can execute the given function. So it returns this because 10 and 50 are the by default value of C. Okay, C and D. So now you should have an understanding of the types of parameters and its required order and how to interpret the required amount of parameters from the signature of a method. Okay, now next topic is allowing only positional argument. So as we saw earlier, if we defining a function like this, calculate interest P, R and N, we can provide both kind of argument to this function. This is what are those? Positional arguments and the keyword argument. Okay, but sometimes or in some scenarios we want user only to provide positional argument and we don't want to accept any keyword argument. Then those argument can be declared using forward slash. Okay, so whenever an argument is marked as a forward slash, all the parameters before that particular function is marked as a keyword argument only. So for this function, P, R and N are marked as a keyword argument only. So if we try to execute it with positional argument, it will work fine. Okay, so here also P, R and N are passed as a positional argument. Okay, but after that any argument can, all the arguments can be, as we are defining where variable arguments of a positional and keyword argument. So after that forward slash, defined argument can be positional or the keyword argument, and following the same order as we defined earlier. So this is also fine. Okay, but if we are providing any keyword argument for one of the P, R and N, it will raise an error saying that it is missing one required argument, positional argument, which is N. Okay, so this will mark as a 3 argument which are required value argument and it must be positional. Same way we can mark argument as a keyword argument only. So for that it is star is used. So after the star parameter, whichever the parameters are defined are marked as a keyword argument only. Okay, so for P, R and N, P can be anything. It can be positional or the keyword argument, but after P, because it is defined here star as a parameter, all the parameter means R and N must be keyword argument. So as we can see, first we are providing P as a positional parameter and second it is a keyword parameter, keyword argument. Okay, so if we execute it with rest of the argument as a keyword, it will work as expected fine. But for R and N, if we are providing any of the value as a positional parameter, it will raise an error saying that one keyword only argument is missing, so it is given as a positional argument. Next topic is attribute of function. So for a function we can also define an attribute. So attribute is nothing but a variable of a function object which is stored inside that object of a function. So function in Python is a first class object, so it can have attributes. So how to define attribute? So function dot, after defining a function dot name of any attribute and its value, and that attribute value we can access inside the function and we can also modify it. So here in this example, what we are doing is we are declaring an attribute count, and whenever the function is called, we are incrementing the value of a count and we are printing the count variable. As this is an attribute, it is not destroyed after calling the function, or it is not created when function is called. It stays with the function object. Okay, so let's execute it. As we can see, it is assigned 0, and whenever it is called, it is incrementing the value of that attribute and it is printing a value, and it is getting incremented each time whenever it is getting called. Next topic is unpacking the list, tuple and map object. Okay, so this is the tuple object, list object. So there are two types of sequence. Okay, this is a flat sequence which are having values like list and tuple object. We can extract this value into the positional parameter. So this is a function point which takes 3 arguments, and we have 3 value tuple object and list object. We can extract or unpack those value to the parameter using star and the sequence. This is a list, this is tuple sequence and list sequence. So it will unpack those value and make it as a positional parameter, which will mapped as a 12 to the x, 15 to y and 19 to z. Same way for the list object. So let's execute it. As we can see here, this value from the sequence is extracted or unpacked as a positional parameter for the given function. Our next topic is key value sequence such as dictionary. So we can also unpack the dictionary object and give it the keyword argument to the function. So as we can see, it is marked as a keyword only argument. So whatever the arguments x, y and z must be given as a keyword argument. Okay, so we have two different dictionary, same dictionary object which are having same value but in different order. So we can unpack both dictionary object, and if we execute, as we can see here, even if it is out of order, because it is a keyword argument, it is mapped to the value key to the name of a parameter. Okay, so this is how you pack a dictionary unpack the dictionary object and pass it as a keyword argument. Next topic is function as a first class object. So we can assign any function to a particular variable. So as you can see here, point function is assigned to the variable point x. So if we check the ID of it, it should copy the memory address of the particular function. Okay, so it is copying the memory address. And in Python there is a built-in method called as a callable, which takes object as an argument and it returns true if an object is a callable object like function. So function we can call using parameter and it will return something or it will do something. Okay, so if we can call it or not, it is written by the callable. So if we execute callable on both object, as we can see, both the function and the variable are callable. So we can call that variable like a function, and if we call it, it will print the given formatted string, as we can see here. Okay, so both point to the same. So definition also returns or defines a variable with the given same name, but it is type of a function. So even if we check the type of a variable or point x, it will be class of the function. And if we check the class of a point, it is also a function. So here def define will, it is a short form of returning object of a class function. So whatever the definition you give it to it, based on that it will return an object of a class function. Okay, so it is nothing but a regular object. Next topic is nested function. As we saw earlier in slides, in Python, function can be declared within the function. So as we can see in this example, there is an outer function, and inside that function we are defining another function called as an inner function, which prints the message from the inner function, and we are calling that inner function within this outer function. So if we execute it, that particular function, it will print the same message. So what we are doing is defining a function. In that function we are defining again an inner function and executing that inner function within the outer function. So this is a nested function. Now what is its practical use? Is it useful? Yes, definitely it is useful. So this is a one practical example of a nested function. So in this we are providing a simple interface, exposing a simple interface of depositing any amount of any number of amount to a particular account number. But internally we have a different business logic for different amount number. So if amount is less than this, then we are taking it, handling it differently. If it is less than this, we are taking that amount deposit as a differently, and if it is more than this, we are handling as a silver gold deposit. Okay, so for each kind of deposit we have a different business logic, and according to it we are taking steps. Okay, so these are just dummy steps in order to only demonstrate you that we are executing a different business logic based on the given amount of rupees. So as we can see here, we have three kinds of different deposits, but we are only exposing a single interface deposit to a user. So user does not know what business logic we are executing behind the deposit. Okay, so just they need to pass two value, amount and the account number. But based on the amount, we have business requirement that for certain amount it should be bronze deposit, for certain amount it should be silver, and for larger amount it should be gold deposit. So if we pass a different amount of for certain account, it should handle differently. Okay, as we can see here, it is handled differently here. As we can see, first is executed as a bronze deposit. Okay, second is executed as a silver deposit, it is requesting approval, and last one is executed as a gold deposit. As you can see, it is requesting additional security for the transaction. Okay, so in here, using the nested function, we are not exposing three different function, but we are simplifying a simple function like deposit, but internally we are calling 3 different workflows. Next topic is returning value from the nested function. So for the same nested function, it may be requirement of a business logic to return some values after executing the logic. Okay, so in this example we want to show the catalog of mobiles based on the given budget of a user. Okay, so internally we have 3 types of catalog based on budget, which is entry level, mid-range and flagships. So based on the amount of budget, we have written the business logic. Okay, so as per the given value, it will return a particular top, execute a particular nested function. Okay, so we just need to write for the given range, we need to write return and execute the particular function. So whatever the value written by the inner function will be again written by the outer function. Okay, and one benefit, key benefit here is to that we might see the change in the business logic as we progress the time, but functionality may remain, or the workflow may remain same as defined inside the inner function. So we just need to change only this part of it, and which is inside the single function. Okay, so let's execute and see the results. So as we can see here, based on the different budgets, it is returning different catalog by executing different inner function. Okay, and whatever the return by the inner function, it is returning to the outer function. So user of this or the consumer of this function only knows this interface, but inside we are using different function in order to break down the workflow into the different strategies as per the business logic. Now next topic is nested function with arguments. So up till now we have seen that nested function does not takes any argument. Okay, but if it is taking any argument, then how we can pass it? Okay, so whenever the nested function is taking argument, there are some terminologies. So first we'll see what are the terminology. Okay, so this kind of nested function is also known as a factory function in terms of design patterns. Okay, so first terminology is a closure. Closure is a function which remembers the local variable from the enclosing scope. Okay, so as we can see here, we have defined nested function multiply xy, multiply x, and inner function is with y, both of taking single argument, and we are returning the value of a x into y. Okay, inside the inner function, and we are returning the inner function itself as a return type of a multiply x. Okay, so this becomes as a closure. So if you are returning a function which is an inner function itself, instead of returning the return value, we are returning a function. Okay, so if we are returning that function, so if we are returning it, it will remember the local variable of a enclosing scope. This is the local variable x. So whenever returning that object, the variable x is remembered by the object or function object with y. Okay, that is called as a closure. So in order to call this function, as it is returning object of a function type or a callable, we can again call it. Okay, so in order to execute with two parameters, first we will call multiply x, which will remember the value whichever given to this, and return object inner function with y, which have remembered the value x, and we are again invoking that function here with value of y. So it has remembered the value of x, so it will multiply it, and when we are calling it, it will return x into y. So let's execute it and see it. As we can see, it prints 45 into 3. Again we are explaining this. So what is happening here? We have defined a function. Inside it we have defined inner function, okay, and returning the inner function as a return statement here with y is the same function. Okay, and inside the inner function we are using a local variable of enclosing scope. This is x. Okay, so whenever you are returning a callable object which is using a variable of an enclosing scope, it is called as a closure. Okay, so because we are returning callable object, we are able to call it second time. Okay, so this is just calling this function which is 45 passed to the variable x, and it will return again callable object, and when it is executed, it is remembering x and returning 45 into 3. So let's first extract the object which is written by it by not executing the second part. So if we break first execution here, and if we check the type of return type of object, as we can see, it is a function because we are returning a callable which is defined inside it. Okay, so it is type of function which is stored in this, we can call it. Okay, because it has remembered the value of x, we are able to call it with y. This is with y with a different name. Okay, so it will print the same value. Okay, and if we provide different value for y, it will again take the same value 45 as a x, and this is as a y. So in certain cases we want to fix certain amount of parameters, we can break down into like this. So what it will do is here, it will fix the x parameter for the particular object, and it is again returning the callable function, callable object. So when it is invoking, it is using that remembered variable to multiply with y. Next topic is free variable. Is a variable used inside the code block, but it is not defined into the local scope as well as the global scope. So as we can see here, within this definition of function which is stored here, we are using variable x, which is not defined locally inside the scope of with y function, and not even defined at the global scope. Okay, it is remembered by the closure object. So it is called as a variable x is called as a free variable. Okay, so how we can say that it is a free variable? So for that, Python has defined an attribute so we can extract the value of a free variable. So these are the attributes. So co free variable, it returns tuple object containing name of a free variable used by the function. So in inner function, okay, so this is the same function we have used earlier, and we are here extracting the inner function or the closure from the multiply x. Okay, so for the inner function with y, if we execute free variable on the code attribute, as we can see, it is returning tuple object containing sequence of free variable. So as we can see, it has written one free variable which is x. So we are using this. Okay, next attribute is co variable names. So it returns tuple object containing name of local variable used by the inner function. So okay, so if we execute it, as we can see, a variable y, it is a list or the sequence of a variable which is local. So for the inner function, only variable y is declared as a local variable. And last one is a co cell variable. It returns tuple containing the name of local variable referenced by the nested inner function. So for the multiply x function, if we want to know which are the variables which are used by the inner function as a free variable, okay, or the accessed by it, so we can write it multiply x dot co cell variable. It will give you the variable names. So variable x is used by the inner function with y. Okay, next attribute is closure. So if we want to access a particular value which is stored inside the closure or the free variable value, you can access it using closure object. So you are wondering that if it is written this object by calling this object, where the value of x is stored, it must be stored somewhere. Okay, for the inner function. So Python stores that value inside this special attribute closure for the callable. So we have extracted the inner function which is callable, which is having one free variable x. So it is stored as a 0th index of a closure cell content. Okay, so if we access the closure attribute, special attribute, as we can see, it contains a cell, which means it is having a variable which is holding an int. So for that we can extract it using index 0, and it contains, which will print the value of that cell content. Okay, so as you can see, the closure object or the inner function which is written by the outer function is having a free variable x, or the return object which is a closure, which is remembering the local variable of an enclosing scope, is storing that particular variable value inside the closer attribute of a particular callable. Okay, callable which is extracted here. All right, next topic is variable and its namespace. So throughout this tutorial we have seen different kinds of scopes. So variable a here defined in the global scope. This is the variable defined in the local scope of a function, and with the introduction of inner function can also have local variable defined inside it. Okay, so if we have, so here we have three different scope, and if we are using same name for that variable, it will hide variable of a enclosing scope. So if we are defining same variable name of outer function, it will hide the variable of outer function and it will declare a local variable with the same name inside the inner function. Same way, if a global variable is having same name with the local variable, it will hide that global variable and declare a new variable which is having a new value. So let's execute it. So as we can, if we invoke it and print it, so as we can see, inner function is having different value, outer function is having different value. Even after executing this, if we are printing the variable value of a global scope, it stays same as the original, because all these functions are not modifying the global variable, but instead they are declaring the variable with the same name in its local scope. Okay, so there are a particular situation in which we may want to modify the variable value of an enclosing scope. Okay, in previous example we saw that x and y, we are just accessing the local value, but now what we want is we want to modify it. As we saw with the business logic of inner function might require to modify the local value of an enclosing scope. Okay, so how to do this? So for that we need to mark that variable as a non-local. After marking that, if we are modifying its value, it will modify or it will use the variable of enclosing scope. So in inner function we have marked the variable as a non-local, and after that we are assigning value to the same object, and if we are printing variable inside inner function, and after invoking inner function, if we are printing variable a in outer function, it should print modified value. As we can see here, 15 is changed to 25. Okay. Now here there is a difference between mutable and immutable data type. So for immutable data type, we need to mark it as a non-local, but if we are accessing mutable data types such as lists, we don't need to mark that variable as a non-local. Okay, so without marking it we can modify it. Why? Because mutable data type object does not change its memory address after modifying it. Okay, so it remains same. Okay, so if we are modifying it, if we define a list variable inside function, and inside inner function we are changing the value of a particular index, as we can see, it will take effect on the mutable data type variable of a outer function. Okay, so you need to keep in mind the type of data type you are using, mutable or immutable, while accessing and modifying the value of a given variable inside inner function. Next topic is, as we have explained earlier, function in Python are first class object. So they are just an object of a function class, as we saw earlier, the type of function. So it can also be passed as an object as a parameter. So if we are defining this is a function, but it is nothing but a variable prime customer which is pointing to the callable object to inside the memory. Okay, so same that it is holding the memory address of a function object. So same memory reference can be passed as a parameter to the function. Okay, so we have in this example we have two types of customer subscription, that is a prime and regular. So based on given parameter of a type of a subscription and order, the particular order is processed. Okay, so instead of passing string or any other data type, here we are providing a particular function as a parameter. Okay, so here, as we can see, we can assign to a particular variable, and that variable can be passed here. But instead of assigning to a variable, we can also directly pass this function as this here. So first we will see by assigning it. So we have assigned this to the variable, and we are passing that variable as an argument to this process order method. What it is doing is, because this type is a callable object, we can invoke it. So it will invoke the given order. So one of this method get executed with the given order. Okay, so we have first argument is regular customer and the prime customer. Okay, so let's execute it. So as we can see here, based on the type of argument which is passed to the process order, it is executing different function. Okay, so we have seen by assigning to this, but we can pass directly the name of the function also. They are nothing but the variable holding the memory address of that particular object. And if we execute it, so it is executing in here. Fine. All right. Here we are providing a different object which should be regular customer. Okay, so if we execute it, as we can see, it is executing fine. So let's execute it both together. So as we can see, first we have providing the callable of a prime customer, and second we are providing the callable of a regular customer. So if you provide any other callable, okay, so it will give you an error. So what we are here, we need to keep in mind that here we are passing a callable to this process order which is taking only one parameter. So earlier it was giving us error because we are passing this parameter, okay, which is expecting two values. Okay, so if it is passing the same function object here, when executing this callable here, it is expecting 2 argument because its signature is having 2 required argument. Okay, so while executing this, you need to keep in mind that you need to pass a similar signature callable in order to execute it. Okay, so here we can pass regular customer which will execute it fine. Okay, so business logic for that particular objects must have same number of arguments, or we can mark it as a variable arguments. Okay, so if it is defined as a var args here, then we can pass it at any amount of arguments. Okay, so for more details on the user defined function, check out the decorators and the func tool section.